Welcome to Kirkwood School District Sound and Light 6th grade science. We're going to take a look today at describing how changes in energy can cause changes in either loudness or pitch, and how we can change the loudness and pitch of a sound. So we're going to be focused on those two concepts throughout this video. Loudness is described as your perception of the energy of a sound. In other words, loudness describes what you hear and how loud you hear it. I love this video because I can only imagine what it's like being in this car as soon as this bass hits and imagining what loudness really is. That is just ridiculous. Look at those speakers move. Crazy. So, loudness of a sound depends on really two factors. First of all, the amount of energy it takes to make the sound. And two, the distance from the source of the sound that you're standing, the receiver, if you will. So if you imagine that you are really close to something with just a little bit of energy, that would be kind of the same as if you were really far away from something that has a whole lot of energy, when you're relating the idea about sound. So think about how close you are to something and how much energy it takes to make that sound. So in general, the greater the energy used to make the sound, the louder the sound is going to be. The more energy you use to, for example, pull a guitar string back, the louder the sound when you let it go. This happened because the more energy you use to pull the string, the greater the amplitude of the string's vibration. So that string's going to go up and down higher and farther because you added that additional energy. A string vibrating with a large amplitude produces a sound wave with a large amplitude. So you can see that large amplitude wave. More energy, higher amplitude. Recall that the greater the amplitude of the wave, the more energy the wave has. Loudness increases the closer you are to a sound source. So if you can kind of imagine ripples spreading out in a circle after you toss a pebble in a pond. So in a similar way, a sound wave spreads out from a source. The closer you are to the source, the sound wave covers a pretty small area and it's pretty intense. But as that sound wave travels away from the source, it covers more area. That ring around the pebble gets bigger, and the wave sort of decreases a little bit because it's sort of spread out over a bigger distance. So the same energy in a larger area equals a lower intensity or a more quiet sound. Great diagram in your textbook right here. Check this out. If you're really close, you can imagine that you will hear a sound, for example, 1 meter. But then if you're 2 meters away, you hear that sound with a fourth of the intensity because you have increased the distance. You've increased that area by 4. And then finally, if you're 3 meters away, that intensity goes all the way down to a ninth of what it was. All right? So if you imagine all the time in elementary school, your teacher saying, using your inside voice, they're really talking about decreasing the intensity so your voice travels not as far. When you imagine these loud, very loud noises, if you imagine these, yeah, that's right, loud noises, loudness is measured in a unit that measures intensity. It's the amount of energy a wave carries per second through an area as its intensity. And that unit, that loudness unit, is called a decibel. Okay? A decibel is a measure of loudness. You can see over here in this table that's set up that there's a set of sounds that are made and the loudness. Okay? So, very soft, kind of quiet music, normal conversation. That's probably where my voice is right about now, 40 to 50 decibels. All right, and then you go all the way up to the jet plane, which is 120 and 160 decibels. Okay, pretty loud, pretty crazy. But your ear can only hear so much and can only take so much. So you can see here that noise-induced hearing damage is related to the duration, how long you're listening to something, and the volume, so how loud it is, what's its decibel. What's its loudness? Government research suggests that safe exposure limit is 85 decibels for 8 hours a day. So, for example, you don't want to have your hair dryer on next to your head all day long. That would cause some hearing loss and some hearing damage. Some common decibel levels, as you can see here. Note the one right here, an iPod at peak volume levels. How many times do we walk around with our iPod at the absolute top volume level? That is dangerous and can definitely cause hearing loss. So something you want to consider when you're thinking about learning about loudness. Our second item that we're talking about today is pitch. The pitch of a sound is a description of how high or low the sound seems to the person. The pitch of the sound that you hear depends on the frequency of the sound wave. And we talked a little bit about this in a past video. And you can see that we have a high frequency wave. This would be a high pitch sound where the waves happen more often. And this would be a lower frequency wave, or the waves happen less often. You can see that as this wavelength, the distance from crest to crest, as the wavelength decreases, the frequency increases. So wavelength gets smaller, frequency gets bigger, causes a higher pitch sound. So when you're thinking about singing, or you're thinking about changing notes on an instrument, to sing different notes, or even to make different notes, use muscles in your throat to stretch and relax your vocal cords. When your vocal cords stretch, they vibrate more quickly as the air rushes by them. So when they vibrate more quickly, we get a higher frequency sound or a higher pitch. When your vocal cords relax, lower frequency, lower pitch. That allows sort of that bass sound. With musical instruments, you change pitch in different ways depending upon the instrument. For example, you can change the pitch of a guitar string by turning the knob to loosen or tighten the string. A tighter guitar string produces a higher frequency sound, and you hear a higher pitch. We've learned a lot about sound and pitch and energy. Let's take a little time to check out a little bit more. Watch this video.
Hi, I'm Mr. Tripp, and today I'm going to be explaining sound, frequencies, pitch, and amplitude. And to better explain this, I'm going to be using tuning forks. Tuning forks are sound resonators that have a U-shaped pattern, and when they are struck, they create the same constant pitch. Now, sound is vibration of particles, and to prove this, I'll strike the tuning fork, and you can see that it's vibrating. To further explain this, I'll strike it again and put it in some water, and you can see that the vibration causes the water to move. Now, tuning forks are determined by their pitch, by the length of the rod. This one has a higher pitch, and this one has a lower pitch. See that they are different sizes. Now, pitch and frequency are very close but different. Pitch is the highness and lowness of a sound, and frequency is the number of vibrations per given time, typically in seconds. Now, amplitude is a little different. So this will always play the same frequency and the same pitch, but I can change the amplitude by how hard I strike it. Let me show you. The harder I strike it, the louder it gets. The amplitude can change from this. Now, to further explain this, I'm going to use a sound whistle. The sound whistle is the same as a regular whistle, except the chamber can change. The chamber is what makes the frequency change. It makes a high pitch or low pitch. So you can see here.
Now I'm using a program called Audacity, and I'm going to show you how the force that I use to play the instrument is going to determine the amplitude of the sound. I'm not going to change the frequency of the sound, but only the loudness or the amplitude. So you can see from the three wave heights that the first one has a lower height, the second one has a little higher, and the last one has the highest height. The last one has the highest amplitude, the loudest sound. The first one has the lowest amplitude and the lowest sound. Now I'm going to show you how, when the frequency changes, the pitch changes. Now I'm going to change this to a different audio track. I'm going to show you the spectrum of the way it is. As you can see, as it starts, I started out as a high note. The frequency was high. Then the frequency dropped, and then at the end the frequency increased again, and therefore the pitch went from high to low, back to high.
More instrument to show you. They're called boom whackers. They're long, clear, plastic tubes. Same diameter, but different lengths. The long one makes this sound, and the short one makes this sound. My challenge to you is to figure out why the longer one has a lower pitch than the shorter one.
Great video. I liked it a lot. We took a look at how changes in energy cause changes in loudness and how we can also change pitch. So, as a fun little ending, the question is, can you get enough energy to actually break a glass with your voice? Well, your friends and mine on Mythbusters tried to figure that question out exactly, and I want you to check this out. It's pretty sweet.
A Mythbusters exclusive. 556 hertz, 105 decibels, and 20 attempts makes for a world first. History's been made, and it's been captured on high speed, so there's really no need to try this one at home.